Hey guys, here are notes for section 9.2. It's on tangents. And we have an activity, so you'll need a ruler or a protractor. A protractor would be great, or a ruler or something like that. I know if you don't have one, you can just use a straight edge and take my word for it, but it would be much better if you actually tried the activity, maybe pause the video right now and do the activity, see if you can come up with a conjecture before I even do it on here. I think that would benefit you a lot more than if you just watched me do it. But if you don't have a protractor or a ruler, it might be a little bit challenging. Use a straight edge of some sort. Make nice straight lines. Don't just freehand them in. If you pause it, do that now. If not, here we go. Draw a line that intersects the circle in exactly one point, which is point Q. So that line would look something like that. We're going to draw a line that intersects the circle in one spot. Then we're going to draw in radius PQ, which is that line right there. And then we're going to use a protractor. Now, if you have one, then I would definitely use it and practice with it to measure the angle formed by the tangent line and the radius. So here's my protractor. I'm going to get my protractor and I'm going to put it right on the tangent line and put it right so that it's at 0, and you can see that it's going to make an exact 90-degree angle. So it says use a protractor to measure the angle formed by the tangent line and the radius. So you could even put that this was 90 degrees. When you measured it, it was coming out to 90 degrees. Now repeat the first 3 steps for point R over here on the other side. So if I do that and I make the line and I make the tangent and then I measure this one over here, my protractor out, put it right on the radius. Oops. Trying to get it to line up, and you can see again we've got an exact 90-degree angle. So again we've got 90 degrees. So point P to Q is 90 degrees. Point P to R is going to be 90 degrees. So make a conjecture about what you think happens when you've got a tangent and a radius and they connect. A radius and a tangent and they connect. What happens when you connect a radius and a tangent? Well, the conjecture would be that the angle formed by the radius and a tangent is always going to be 90 degrees. It's always going to be perpendicular. A tangent line and a radius are always perpendicular. Pause it if you need to. Let's move on. On the coordinate plane, the radius of a circle lies on the line y equals -4/3 x. So -4/3 x is this line right here. It gives it to you right there. And it's plus 0 because it's touching right at the 0, 0 point. So y equals mx plus b. b would be 0 in this case because it's touching at 0. If I go over 4 and go rise over run. So I go over 3 and down 4, you can see that that's where I got the -4/3 slope. Now it says find the equation of the line. So we're looking for an equation of the line that is tangent to the circle. So find the equation of this tangent line right here. Okay, so what we want to do is look for our tangent slope. Well, we know that if my slope is -4/3 of this radius, which it says right here, then the tangent slope has to be a positive and a reciprocal. So it's got to be a positive 3/4. So I already know what my slope is. My slope is going to be 3/4. I also know that this point right here is on the line, which is over 12 and down 16. So I know, because perpendicular slopes being opposite and reciprocal, because so that's a -4/3, perpendicular is going to be positive 3/4. Now the point of tangency is this coordinate, which is over 12 and down 16. So I know my slope and I know a point. So I can use what we call the point slope form. This point down here, by the way, was over 12 and down 16. We can use what we call the point slope form, which is that formula right there. Y minus y1 equals m slope x minus x1. Here's your x1 and your y1. Plug those in and plug in your m. Your m is right there. So that's what it would look like when you plug it in. -16 was your x. Positive 12 was your -16 was your y. Positive 12 was your x. simplify by distributing the 3/4 and getting rid of the double negative, and then subtract 16 on both sides, you will have your equation of this tangent line. It's a positive 3/4 minus 25. That means if you extended this down, it would touch at negative 25. Equation of the line tangent to the circle. We use the information that they gave us. Now, is EF tangent to this circle? So how would I know if that's touching or it's barely not touching, or if it's barely going through and it's a secant? Well, we just learned in that first activity that a radius and a tangent have to make a 90-degree angle. So if it's truly a tangent and it is touching in one spot, then this would have to be a right angle, and that would make that whole thing to have to be a right triangle. This DEF would have to be a right triangle, which means we can use the Pythagorean theorem to see if it's a right triangle or not. If c squared, which is 61, if 61 squared equals 60 squared plus 11 squared, then you know you've got a right triangle if c squared equals a squared plus b squared. So if c squared is equal to a squared plus b squared, then it is definitely a right triangle and the line will be tangent. So let's see if it is. Is 61 squared equal to 11 squared plus 60 squared? Now 61 has to be c because it's across from where the right angle would be. So 61 squared is 3721. 11 squared is 121. 60 squared is 3600. And yes, 3721 equals 3721. It is a right triangle, therefore it is a tangent line. This EF is tangent to the circle. Here's a challenge for you. I would try it first. Pause the video, give it a try, see what you get. Plug it and get your answers in here, and then watch me do it. And try not to shortchange yourself. I would definitely try it on your own first, because it makes it a little more of a challenge and more learning experience. That says, what is the equation of a circle with a center of negative 2, 5, which I've given you the little red cross right there, and a tangent to the x-axis? So the circle would actually look like this. It's going to have the center at negative 2, 5, and it's going to touch the x-axis, tangent. We want to know what's the equation from the last section. We learned about the equations of circles. So basically what you have is, this is my equation of a circle, radius squared, x minus h squared plus y minus k squared. H and k are my center points. So I'm going to plug in the radius. How did I get 5? Well, I counted 1, 2, 3, 4, 5. Radius has to be 5 because it's going down to 0 and it was at 5. So 5 squared equals h, or x minus h. We know h is negative 2 and k is 5. Plug those in. So my equation of my circle is 25 x plus 2 squared and y minus 5 squared. That's the equation of the circle. Hopefully that's what you got. Moving on. Okay, here's the second activity. Again, I would try these on your own. Get a ruler. All you need is a ruler this time. Get a ruler and try these 4 steps. Make a conjecture. See what you get. Pause the video. Try it yourself. And then put on the video and it'll see if you did it right or not. That makes it a little more challenging, a little more interesting rather than just sitting there listening and drawing everything down. But try it yourself. Draw as many tangent segments as you can from point Q. So if you can, you only draw 2 of them because you're going to have tangent to one side and a tangent to the other. There's no other tangents. So label both tangents as A and B. Okay, there's A and there's B. That's where it's touching. Measure and compare AQ and BQ. So here's my ruler. I'm going to put this here at 0 centimeters. I'm going to measure BQ right there, and if you notice it's 80 millimeters, which is actually 8 centimeters. And if I go over to AQ, it's exactly the same, 8 centimeters, or 80 millimeters. So both of them came out to be exactly 8 centimeters. Both of them did for mine. Now yours might be different because you could make a different point or your paper's different, but mine came out 8 centimeters. So my conjecture would be this: 2 different tangents drawn from a common endpoint are going to be congruent. If you draw 2 tangents from the same endpoint, they're going to have the same length. That's the conjecture. All right, moving on. In this figure, the sides of the triangle are all tangent to the circle. Look at this triangle's tangent, this side's tangent, this side's tangent. So the circle is said to be inscribed inside the triangle. Inscribed means inside. Inscribed in the triangle. This triangle is said to be circumscribed about the circle. So it's outside. Circumscribed is on the outside of the circle. So that's little vocabulary terms there for you. Now let's use the information that we've learned. We've got the same kind of picture here, and it's asking us to find the perimeter of this circle. And there's going to be a few pieces that we're going to figure out. But we know from just the last activity that AP and AQ are equal because they're a common endpoint and they're both tangent. So if this piece is 2 cms, then this piece also has to be 2 cms. There's no other choice. They're both the same. And the same is for CQ and CR. So if this one is 3 centimeters, then this one must also be 3 centimeters. And if this one is 4 centimeters, then this one must also be 4 centimeters. So there is all your points. Your perimeter now should be a piece of cake. You're just going to add up all the sides. Basically what you've got is you've got AP and AQ are both 2's. 2 2's makes 4. 2 plus 2 is 4 there. CQ and CR are both 3's, so 3 plus 3 is 6. And then BR and BP are both 4. So 4 times 2 is 8. So your perimeter is going to be 18. When you add all these together, you're going to get 18 centimeters around your triangle. All right, example 4. What is the area of the regular pentagon? Now we're applying things that we did from previous chapters, because in a previous chapter I showed you how to get the area of this pentagon. You probably forgot. Understandable. So I'm going to review the formula with you. To get the area of a regular polygon, you'll probably remember the formula once you see it. 1/2 times the little a, which is the apothem, times the big P, which is the perimeter. So if you can find the apothem and the perimeter and multiply those two and cut it in half, you'll get your area of this pentagon. So with the information that they gave us, we should be able to find the perimeter. There's each side's 8. Because this piece is 4, that means the whole thing is 8, and you got 8s all the way around. You got 5 8s, so you get 40 centimeters. There's my perimeter. P's done. All I need is A. If I can find A, I can plug it into the formula and solve it. To find the apothem, which is our little a, what we need to use the right triangle down here at the bottom. This is a right triangle, so we need to fill in pieces that we know. Right now, to find the angles in a pentagon, this is again another chapter, you probably remember, to find out all 5 angles in a pentagon, we have to use the n minus 2 times 180 formula. 5 minus 2 times 180 is going to be 540 degrees. So all 5 of these angles, angle A, B, C, D, and E, will add up to 540 degrees. If you divide it by 5, that means each angle is going to be 108 degrees for each angle. So you can see it right there. That angle is going to be 108 degrees. Okay, so that's first part, defining the apothem. We're still looking for little a. Okay, that's our main thing here. Okay, so now each angle is cut in half to make the right triangle. So you see how this C angle, which we know is going to be 108, same thing with here, B, they cut it exactly in half to make this triangle. So therefore, all the 5 congruent triangles have base angles of 54 degrees. So there's my 54 degrees right there. So we're building this right triangle. We're finding pieces that we know. We know this is 4 centimeters from up here. We know that this angle now is 54 degrees. Okay, the last part here says use the tangent ratio to solve for little a. So what we're trying to do is we're trying to solve for little a. We want to get little a, right? Oh, right there. There he is. Oh, had him. Okay, let's try again. he was supposed to come up earlier, but he didn't. So we'll just put it there. There's a little a for you right there. Okay, that's what we're trying to find. So if I use the tangent ratio, the tangent is opposite over adjacent. So OA, TOA, TOA. So that's why I used tangent of 54 equals a over 4. If I multiply both sides by 4, 4 times the tangent of 54 is going to give me about 5.5. So it's approximately, you can see the squigglies, that means it's about, it's rounded off. So therefore my area, because I now have the formula up here, it's 1/2 times A times P, and you're going to get approximately 110 square centimeters for the area of this whole regular pentagon is approximately 110 square centimeters. And that's it. Don't forget the practice problems. Very important to do the practice problems. You know, you're going to miss out on the activities, you're going to miss out on the points for the homework if you don't have the practice problems done. All right, we'll see you guys later.